Very good afternoon to one and all. Myself Supriya, Technical Sales Engineer, PWSM Engineering Solution, GMAC team. Firstly, let me introduce you to what is Pavasys and who we are. We are Pavasys, like we are a Europe-based company, and we have started in the year 2002. We have 8 offices across the world and 2 offices in India. So we have more than 50 plus employees who are working in the different domains such as power system, electromagnetic design, and power electronics. So how the name PWSM Engineering Solution? So we are an Indian subsidiary of the PowerSys Group, so which is named after that in India, Indian offices. We have over 15 to 20 million dollars turnover up to now, and we are doing good in all the fields what we serve. So yeah. So I'm stuck anywhere. You can disturb me in the between, and I will take over from there. So our main motto is like revolutionize e-design, accelerate, and electrification. If you are going with the proper e-design with the e-cycle verification and validation, you can accelerate the electrification process here. So who we are. You can find the team whom we are working around and the office which is placed in the France and all the teammates who are working in the different field as I told. So we are specialized in a model based design simulation software. So we have 50 plus electrical engineers from North America, Europe, Asia, and as I told, from all over the world. We are focused and working on the EV mainly. And what we do, like we reduce the time for new product development, reduce the cost of the development, help to design more efficient products, help your designers to understand their products in detail, help your product to get a green brand, mainly you can tell energy saving concept. So yeah. We are now 20 years and we have delivered our solution to more than 2,500 customers in across 80 countries, enabling our clients to solve their complex electrification challenges in EV and grid. So these are our offices worldwide, which I just told you, and we are located in USA, Europe, Canada, Paris, in Germany, and in India, as well as obviously I told you 2 offices in Bangalore and one in Chennai. So how we decrease the time to market? We increase design robustness, we increase simulation volume, decrease simulation time, optimize design workflow, and integrate IT. We help in the increased simulation volume through faster computation optimization. We decrease simulation time by parallel processing. We optimize workflow in such a manner that gives automated and optimized output. So we also have the compatibility to the graphical user interface and programming languages. So we are experts in electrical designs and which helps with deals with the design, electromagnetics, power electronics, and multiphysics simulations. So what is the value proposition we give? So overall, we are expertise in the simulation tools, and our software includes JMAG, which is an electromagnetic tool, which is the prime focus of this meeting, and also the Simba, which is a power electronic tool, which helps in the giving you the power electronic devices output and help you in all those. So yeah, we also provide the simulation of the software power computing, which helps in the high design workflow performance. What value proposition we give? Like this will help you in increase your speed of the simulation indirectly, reducing the time to market by running the simulation on parallel and distributed computing. Overall, we provide exact course and processes for intensive and exhaustive simulation. This will help you in your day-to-day projects. And these are some of our simulation tools which we are serving to all our customers. As I told, JMAG, which is an electromagnetic tool, Simba, which is an power electronics tool, which is been handled by our Chennai team, like. And also Romax for noise and vibration, Actron for harness, computational for particle works and dynamics, uh, competitively. So as I told, like what power computing like we'll be doing like unlimited parallel computing by the software what we use, like cost effective, ready to use licenses. and all these things. So yeah, like coming to the like software, like what unique point are we going to like provide you? So we will be supporting on the SMP, MPP, and GPU. So we are experts in like providing the cloud services. We also help in the mesh modeling. We also help in the creating a complex coil and geometry. We are also providing the material modeling when you come up and take up your projects to work on the software. So we are like also experts in the JMAG Express for the motor designing. So multi-objective optimization is the main focus, like what we work into, and experts in that. So efficiency map and topology optimization, and of course the real time is been included. Rather than going for the single software, you will have a combination of all this. So this is where we are. So yeah, how do we process with? So once we take up the projects and we go through all the steps. So we start with the audit and understand, and our support team will get in touch with you, go with the evaluation and benchmarking. So understand the design workflow and simulation pattern, test all the things, deliver and train and maintain, and configure your license to your system. So this is how the process we follow, like step by step. So yeah, coming to our inspiring clients. So these are the some of our clients whom we are working with and serving from last 20 years. So yeah, when we come to like automotive industry, it is Mercedes, L&T, yeah, Kirloskar, Powertrain. We can go to the Magna and home appliances, Havels, and many more to go. And some of the institutions also who have been given good references to all the companies, and there many more are upgrading year in year. So yeah, this is where I am. Thank you. So I can hand over to my colleague, Ms. Nitara, who is a FEA support engineer. I think she can take over on today's topic where we are going on to.
Thank you, Supriya. Uh, Greetings, everyone. Myself, Nitara. I'm application engineer from PwC Engineering Solution, subsidiary of PowerSIP. Today, I'm going to give a brief introduction or explanation about the topic that is enhancing IPM motor efficiency by understanding operating region and efficiency map. So first, I would like to introduce what are the outline we will be going to cover for the today's discussion. First, we will be briefing out overview of efficiency map. Though we are discussing about what is the meaning and what is the importance, everything regarding the efficiency map. Afterwards, we will be taking one example to get how the generating efficiency map, lows, operating point, and using JMAC designer. Under that, we will be covering the importance of efficiency map, the analysis target, what we have used for this analysis purpose. Then there will be a discussion regarding how the efficiency map analysis is happening in the actual phenomena versus analysis model. So next one, that is exporting results. Then we will be discussing about creating efficiency map by using two different methods. Then efficiency map accounting for AC loss, user conference details. There we will be seeing some of the papers what they have presented some of the user during the conference. Then some example for the white papers. After that, we will be concluding about our topic. So first, I would like a brief introduction about the efficiency map. As we all know, efficiency is one of the important factor that we need to understand in our design world. So whatever any of the motor or any of the application or we are going to design in, there is one of the key factor that is efficiency. Because we want to know, or if we want to understand whether we achieved our design work in a proper manner, to understand what is our efficiency we can achieve through that design. So to understanding efficiency before making a prototype or before making a model, getting the value of efficiency or getting the idea of efficiency will be a grateful. So to understand or to get an idea regarding efficiency, we are doing the analysis that is known as efficiency map. So in detail, if I can explain regarding efficiency map, means efficiency map for an electrical machine is a counterplot of the electrical machine efficiency on axis of torque and speed. So that means here in through the analysis we can get a counterplot. That means it's a kind of a map. There we can get the efficiency with respect to two axes. That will be, one is the torque, another is the speed, and it describes the maximum efficiency for any speed or torque combination and is a convenient way to represent the motor drive over a range of operating points defined by driving cycle. Because as I mentioned in the earlier point that efficiency, understanding efficiency is very much important, because we have some consideration regarding our all of the design. That means our model should work with the maximum efficiency for any speed or maximum torque, or if both the combination. So this should happen during our analysis purpose. So how we can understand that analysis, or how we can come to that point? So for that and all, we can easily help our efficiency map, that too in different operating point. As we know, our any of the model can operate in different points or different way. So in each of the point we can understand the proper value of the efficiency. The next one, this session, we are going to demonstrate how to create efficiency map using a tool called JMAC design within a few steps. So the efficiency map analysis I have completed, and I will be showing some result. For that, we obviously doing a software. That tool is calling as a JMAC designer. So by helping with the help of this JMAC designer, we are going to obtain the efficiency map. So regarding JMAG designer or the tool, I will be explaining in the later slides. So first we can understand how this efficiency is varying with respect to real-time scenario and in the software. So first we can see that is a test bench for motor efficiency analysis. So for this analysis purpose, we can do speed and torque sensors are crucial part with the dynamometer, as it allows accurate measurement of motor performance, providing data to easily calculate input output power and efficiency. That means obviously we know calculation of efficiency we can be do with the help of input and output power. So once we are knowing the value of the input and output power, it can be easily understand our efficiency, or we can calculate our efficiency. For that, in real time, what we are going to do means we will be having some sensor that is used for finding the speed as well as torque, that will be connected with the dynamometer. So once we are getting the speed and torque, we can find out our power. Once we will be getting the power, from that we can find the efficiency. But testing electric motor with a wide range of power output ensures that they operate at optimal efficiency. That means we need a set of power values to understand the optimum efficiency, because there are different operating region. If I can take an example like low speed, high load, or low load and high speed, in that different region, operating region will be available for any of the machine. So for each of the cases, how much power or what is the different values of power can be calculated, should be calculated. From that we can understand the optimal efficiency. So this phenomena is happening this way, that is demonstrated in this figure. That means I can tell that here this figure is indicating is the workbench that is used for the efficiency analysis in real time. So obviously we will be having a motor with a drive circuit as mentioned in the figure, and as we discussed in the previously, that means to understand the power or efficiency we have to get the power. To get the power, we have to get the speed and torque. For that, we will be having some sensors, and that sensor with dynamometer is mentioned. So with the help of that, we will be getting the power. From that, we will be able to find the efficiency values. So this is the working model, how it will be during the real-time analysis. But obviously, there will be some challenges in the real-time efficiency mapping, such as the excitation parameter like phase, current, amplitude, everything should be precisely controlled over a operating cycle with a drive circuit, because we know there should be set of phase or current amplitude to get the corresponding values, but these values should be properly operate means properly precisely should controlled, because we have some condition that we should obtain the maximum torque or maximum torque and maximum power output condition. For that, these two parameters should be precisely controlled. That will be little difficult in the real time scenario. And another point, that is the difficulty to find the optimum efficiency at each operating point by measuring input and output power. As I mentioned here, we are finding efficiency with the help of input and output power. From that, getting the optimum efficiency also not a very easy task. So from these things, we can understand in real time, finding the efficiency of any of the motor drive system will be difficult. So for that only, we are giving a solution here, that is by using the software tool we can easily understand the efficiency map. So to get the efficiency map, before that we should understand that what is the main importance of the efficiency map. So here we have listed out some of the importance, such as that the motor efficiency map is one of the important evaluation item in the motor drive system development. As I mentioned, whenever we are developing any of the model or any of the design, we have to understand or we have to verify initially whether our requirement of the efficiency is satisfied or not. So that is one of the key factor. Another one, that is for selecting a design of motor, whether maximum output, maximum torque requirement are met, that can be confirmed. So obviously, if you are going to design any of the motor, first we have to understand two factors such a way that maximum output and maximum torque. So these two are whether it is we have got it or we met those factors. Then that also we can easily confirm with the help of efficiency map. Another, the third point, that is a creating efficiency map for both motor design and control design can be useful due to efficiency varies in accordance with the rotation speed. So all this point, it is clear that efficiency map we have a very important in the designing of any of the motor. So this figure also illustrating different motors example where we have the objective such a way that our maximum output and maximum torque condition should be satisfied. So this red line is indicating at different point each of different motors are here, where we can which point will give the our condition, means which point is satisfied our condition. So from this we can get a good idea about which design of motor we can select it. So here I'm going to give a introduction to JMAC Designer. Actually, as I mentioned in this webinar, I am going to discuss about efficiency map by using the tool that is the JMAC Designer. So actually, this JMAC Designer is a electromagnetic tool. It will be working based upon FEA. That means JMAC Designer is a FEA based tool to create torque, speed curve, and efficiency map. So let me explain in detail what you mean by FEA based tool. We know there are another tools that will help us to find the analysis with the in analytical manner, but FEA, that full form of the term is finite element analysis. That means this is a matrix we are using to understand or to get the analysis in any of the model by making different finite element or finite element. So it will give us a very accurate result. So this tool will help us easily to get the efficiency map as well. So JMAC Designer is a in JMAC Designer efficiency map that account for the effect of iron loss and nonlinear magnetization characteristics also can be created with very easily. That means JMAC Designer, the tool have some other features such as one is it have the good solver. So that means it have an advanced solver algorithm we have in our JMAC software. Another feature, that is the material database. We have a best database from manufacturer. So lot of more than 1,000 elements is available in our material library. Another, we will be having a good measure. So anyway, as we know, FE analysis should happen with the help of meshing. So this mesh can be, JMAC will help us to create a optimal mesh as well with the different methods. Then next the thing is modeling. Fast and detailed modeling we can do with the JMAC Designer. So these are the main key attractive point of the JMAC Designer tool. So we will move to our main topic, that is I'm going to convey the information that how we are going to do the efficiency map analysis. For that, I'm taking one example here. As we mentioned, IPM motor efficiency map analysis we are going to discuss here. So here, as the first figure is indicating that the model where I have taken IPM motor, all the part of the motor have mentioned here such a way that magnet, rotor core, coil, stator core, everything's are available here with the pole of 8 number, slot with 48, and the material whatever we used for different parts mentioned in this table. And here we can see it's a supply details. It have three-phase supply with the 5 turns and phase resistance and the slot connection, as well as the winding has mentioned as per this figure. This is a distributed winding connection and it's a star connection. Then the drive details. So basically the supply, the giving through drive, the drive have the details as mentioned in this table. So these are the my details where I have taken an example to understand or to get a result of efficiency map. So some precondition also we have taken here such a way that rotor is rotated at a constant speed and supply we have taken as a three-phase AC power. Now, I will be discussing about how in actual phenomena and versus analysis model. So, as we know here, efficiency map of the IPM motor only we are going to discuss here. So, our main analysis objective already I have told we are going to analysis with the help of my previous in this IPM motor we have taken as a target, and in this we are going to find out the efficiency map. Because I have taken IPM motor is as an example here mainly because of the torque characteristics. In the IPM motor, as we know, along with the magnetic torque, we are getting the reluctance torque as well. So IPM motor can possession of wide range of operating region, so it is very highly efficient. So here, efficiency map require a significant amount of calculation, and organizing result can also take a considerable amount of time in the real time. So we have seen if we are going with a software tool or any other tool, it will help us to get an calculate or getting the value of efficiency in a reasonable time. So, if by efficiency can be calculated with the help of torque, voltage, and current from the motor voltage equation and torque equation. So, in that way, from the these parameter like voltage, torque, everything, we can find the efficiency as well as when estimating the loss also. But obviously, we have some challenges for that type of method. So, only we are moving this method here. So in this, we are going to compare in the actual phenomena how it is going to happening, and in the analysis model with the help of the software tool how it is going to happen. So in the first block diagram is explaining about the physical phenomena. Here we can see that when we want to create an efficiency map, first we have to get a constant speed. Example kind of servo motor, that means targeted motor should rotate at a constant speed for an example servo motor. Then another the main condition, that is that current is varied to maximum output, or like here we can see current should be it should be varied. Because mainly why I want to current should vary means we should get our we have an objective that we should get the maximum output power. That is the one thing. So once this is once we have or maintain this condition, we can drive the motor. Then we can get the power values. From the power value, we can check whether our two condition have satisfied. That means whether our power or efficiency, whether it is maximized, and voltage, or whether it is in limit or not. So these two conditions should be satisfied. If not, what we can do, it means either we can change the phase or we can change the current. As per these values, we have to change and we have to run the motor. From that, once when we satisfied both the condition, we can find the efficiency. This is the phenomena we are going to do, or it will be happening in the physically. But when we will move to the analysis model, that means to evaluate the phenomena produced by the process with an analysis model, a motor response value table should be created. That is the first step. So here, while changing the operating point to operating point, that means as we know, the motor has different operating point. Each operating point should be taken considered, and in that efficiency map has to be identified. So that will be happening in the analysis by with the help of response value creation table. So here the response value table is used to search the operating point where the output efficiency is maximum within the range that satisfied the voltage limit and current limit. That means in the physical phenomena we are checking, and we, as per that we should change the parameter. But here in the analysis model, the response value table itself can find out the operating point where these two conditions has satisfied. So once they can find it, from that we can get the voltage, torque, efficiency, all those value. So after, and we can get those values, we can find the efficiency map as well. So that is the mentioning here. So we can see here how the response value is helping us to find out the all the limit values. That means we should attain our objective. From that, how we can get the voltage, torque, efficiency value. From that we can find the efficiency map as well. So this is the main difference between the physical phenomena and analysis model. Now I can tell about our software, our tool that can be very user friendly simulation platform, because the steps I have mentioned here in this figure. Obviously the first step, by as we are using JMAG designer, we have to create the motor model using a JMAG designer module. So this is our motor model where we have to create it. So we want to obtain the result, whichever motor or whichever design you want to get the efficiency map. So that motor model should be designed first. That is the first step. So magnetic field analysis model, we should create it. And response value, next step is response value table is created by performing the magnetic field analysis. The main reason, or why we are going with the response table creation, means to obtain the flux linkage, inductance, and torque. So the second step, that is a setting and response table creation, as we have seen here in this figure. In the response table, we have the option such a way that current we can give the value, a set of value we have to give, phase and the speed. These terms we can give here with respect to our operating range of the model. Then with the help of this table, we are able to obtain the motor flux linkage, inductance, and torque corresponding those values. After setting these all things, we can get the maximum voltage, maximum current, and control method, etc. We can create the efficiency map. So this is our end result, that we are going to get the efficiency map. So not only efficiency map, we can get the loss, LDLQ map, and TQ, all those things we can get it from the essay result. So from this we can understand this platform is very user friendly. It is very easy to understand any of the fresh person who is going to handle the software, and from that very less information need to be imported in the software as well to create the efficiency map. Now we can discuss about the result. So as the analysis target, I have shown the model, and the method how we are going to do the simulation also explain and show the main point what we have to enter the values and how the working is happening. Once we will do the analysis in the tool, we will evaluate that and we will be getting a set of results. The result is mentioned here. So the first main result, that is a efficiency map, obviously, as our main target is efficiency analysis only. As I mentioned, efficiency map, it will be contour plot with respect to two axes, that is speed as well as torque. Speed will be in R per minimum and torque will be Newton meter. efficiency will be in percentage. So that's what mentioned in this figure. So for that efficiency map, before analysis are run in JMAC designer, response table, as I mentioned, we have to create with the help of current, phase and speed, with the priority given to the speed are set from response table creation. So that is the first step we have done. Then after that, we will be running the analysis. Efficiency map is displayed after setting the inverter setting, motor control mode, mechanical losses, everything in the dialog box. That means once we will run the analysis, these all terms we have to set. That means it will be post processing. After evaluating the analysis, we have to add these all the thing. That means inverter rating, motor control and mode and mechanical losses. All things should be added. After that, our efficiency map will be displayed. So that is shown, that will be getting like this. So here there are other option also. We can adjust our rating, means from which minimum value to maximum we can get. And obviously this figure you can see both motor and generator mode also is visible. That also we can edit it as per our requirement. All those things we can do in this analysis, in this result. That is the first result, that is known as efficiency map. Along with that, other result also will be there. That is one of thing is iron loss. Iron loss also, as it is totally showing, because that is can be seen for separately stator and rotor, because we are giving condition for separate stator and rotor as iron loss condition. So it can be visible for separately as well as total value also. That also can be seen with respect to speed and torque. And the third one, that is a total loss map, that is the overall losses. Maybe suppose from the efficiency, if we know the output power, if we are interested to input power or any other way, we can to get some values with the help of total loss. You can get the value from this total loss as well. So other than that, one of the important point from this efficiency map is loss ratio at each operating point. So each operating point here, we can see this is the region, and from this figure we can understand which region will be getting maximum efficiency and which speed and which torque it will be getting maximum. That everything we can understand. In similar way, this figure, down figure, all this pie chart is helping us to find the loss ratio at each operating point. So each this pie chart I have selected, and we can create at each point. As per our requirement, we can select the points and we can create on that points corresponding pie chart. These pie chart are for the different condition that we can see here is a low speed, high load, and this is for low speed and medium load, and this is for medium load and medium speed and medium load, and the last one is for the high speed and low load. So like this different conditions I have taken. In each condition we can see how the loss is varying as well. So what is this? Each color is indicating each different type of losses. We can see grays, DC copper loss, AC copper loss, like the different losses are in different color. So each operating region, how the losses is varying also in a set of the pie chart we can understand. So what we can get an idea from this, that DC copper loss, that is in gray color, it was high at no load, and no, it's a high at low load, and it is very less at high load. That means DC copper loss is decreasing according with the load. Same way, AC copper loss we can see that is in brown color. It is representing that it will be increasing in according with the speed and load. That is the second means conclusion we can get here. And another one, that is it can be seen that the loss of the stator core increasing according with the rotation speed as well. So this, like this, each comparison we can done with the help of the pie chart. So this pie chart can be created at each operating point, that is as per our requirement. Here I have taken some example as per the load and speed, and we can analyze the losses as well. Now we have seen a set of plot that we can get an output of this efficiency map analysis. But other than that, so many other results also we can get it, that has mentioned here, that is AC copper loss, iron loss plus copper loss, eddy current loss, PWM eddy current loss, mechanical loss, speed IDIQ, speed IAM and phase, all this kind of plot also we can get it along with the efficiency map result. That has all the examples also I have mentioned here for copper loss, AC copper loss and eddy current loss, PWM eddy current loss, magnetic eddy current loss, mechanical loss, all those result also we can get it as the output of the or as a result of the efficiency map analysis. Now, as all we know, we can understand the efficiency of any of the model from this result, but that is not needed, not only needed for us. Maybe we were looking for doing some other calculation or some other way we want to pretend this result. So for that, there are different methods are available also in the software that we can export these result in three different ways, such a way that first one is in PDF format, that's .pdf, you can save the result. Next one, that is an image format. Any of the format that mentioned here, we can keep it and we can save it. The third one, that is very much important, that is CSV format. That is a in Excel we can get all the data, so as per our requirement we can segregate the values and we can do the further calculation as well. So this way also this tool will help us to understand and do the further study about the result also. Now, as we have seen one example how to create the efficiency map. Actually, creating efficiency map by using the GEMAC designer tool, there are different types are available. We have seen that example is depending upon the speed priority mode. Other than that, we have another one more method, that is a accuracy priority mode. So in this slide, I want to explain in detail about these both mode, how it is different each other. First one, that is a speed priority mode, that is already we have seen in our example. Here FEA of or FEA analysis happening for the multiple points are run in single case and one map is created. But in the case of accuracy priority mode, FEA of multiple cases are running, because each operating point they will be considering each cases, and like that it will be it will do the analysis, and but we can create a one map we will be getting from the accuracy priority mode. Speed priority mode we can do very fastly and can be calculated in local workstation as well, because this will not take much time. It can be do in a average speed, means average time it will be taking, and it can be done in any of our local workstation. But accuracy priority mode, as we mentioned, this is little more vastly, it is taking all the operating point as it want to do. We need some other high-end kind of the working environment. For that, HPC or PSL kind of the software is needed to do the accuracy priority mode in quick manner. Then other features for the speed priority modes are first one, stress distribution, string fit, everything we can understand, and losses including magnetic loss also can be considered for the speed priority mode. Drive cycle, that is calculating the average efficiency over the drive cycle, can be also possible in the speed priority mode. So in detail already we have explained how the working is happening and what all things we can understand. Everything can be already we have explained in our example, that is actually mainly based upon the speed priority mode. But accuracy priority mode means main point is we can get more accurate, because all the results, I can tell example like AC copper losses like in the coils cannot be added in the speed priority mode, but that can be used with the help of RT, that is another version of our software. In that we can be use the FEM conductor. With that we can understand or we can find out the AC copper loss. So like that all over the losses we can get it, and with from that we can find the efficiency map. So obviously it will be more accurate. As we I have explained, it have more cases and it will be taking much time for the simulation. And here the circuit, all the control circuit also can be applied in this analysis. So that's why that are the main features of the accuracy priority mode. Now another one example for efficiency map accounting for the AC losses. That means as we explained in our example, there we were not considering the AC losses. That means in speed priority mode, we are not like PWM induced tire loss is accounted, but not coil AC loss we are not considering. So if you are interested or if you want to do that as well, and we want to find the AC loss also, that can be also possible in the tool. So that can be how we can do. The procedure is explained here. Either if we are doing with the speed priority mode, means we have to convert efficiency map not accounting for AC losses for speed priority mode, as I have discussed. So in that we have an option for JMAG RT model. So we have to convert to JMAG RT model, and there we have to give the coil AC loss as well. Then we have to accounting efficiency map accounting for AC losses also we can create it. That is a one way. Otherwise, from the accuracy priority mode, if we are running from that, we can easily add directly the AC losses. So from that also we can get the efficiency map. So these two figures are illustrating how the efficiency map will be looking without AC losses and with AC losses. So both can be see the variation in the values and all the region, everything can be varied because this is without AC losses and with AC losses. So all those things we can accommodate and we can understand our result with the help of this tool. Now we can move to some user conference details where some of our users with this means by using the JMAG tool, they have analyzed the efficiency map, how they got the result, how they have explained in the paper, have brief out here. So I took some examples. We can check each of them. First one, that is a load influence on AC resistance of high speed permanent magnet electric machine for electric vehicle application. This is from AVL software and function GmbH. That is the company name where they have presented this paper. So here actually they are mainly focusing on the AC copper losses, as we discussed recently, become increasingly important because in electrical machine design, it's very important nowadays. So we need especially for high speed EXL application. So this users main intention was finding the means finding efficiency map by accounting the AC copper loss as well. So a case study of machine design with the accurate AC resistance calculation is presented here. So the result of AC resistance variation as well as the impact to the efficiency map are illustrated. So by changing the AC resistance, they understood that obviously that the effect will be coming in the efficiency map also. So this is the result comparison in the unit they have tried to process, and they have analyzed the model and they got the result. And even by using the JMAG tool, they did the processing and they got the result, and they were indicating that high efficiency is the same with JMAG efficiency. So highest efficiency is similar to JMAG only they are getting. So torque and speed curve between two processors match very well. So that is the thing here. We can understand that with the software or with the tool also, we can get the result in proper way by for understanding the efficiency map of the model. The another paper, that is a development of analysis and design technology for motor technology research in association of magnetic material for high efficient motor, that is Dakin Industries Limited. So they have explained actually their objective was they want to change the magnetic material of the magnet by using, instead of like mainly we will be go with NdFeB magnet. Sorry, that is a conventional magnet. Instead of that, they develop mag HEM. It will give the high performance. So that material they used and they have changed the magnet. Similar way, high efficiency designs were created using high magnetic force magnet, and they tried to reduce the 30 to 40 percentage of losses were achieved through analysis by varying rotor shape. So we can see instead rotor shape also they try to change, and as well as magnetic material also they try to change, and they want to understand how much each of the design will give us the improvement in the efficiency. So that also, for that purpose they use the this tool, and they got the result here, and they got the understanding also. If we are going with the high magnetic property material and a low iron loss material, they are getting more efficiency compared to other normal structure as well. So that comparison is showing here. So that is the result also they have mentioned in this way. Then the third paper that is discussing about the efficiency map generation and simulation of dual three-phase PMSF. That means here the supply is mainly dual three-phase supply they are giving. This is from Mercedes-Benz. They have explained about this topic. Here a detailed view on efficiency map and controllability of dual three-phase machine is spent to describe the special characteristics of machine type. So this can be possible even for this type of machine as well. So dual three-phase PMSM excite large low-frequency current harmonics which need to be considered in accurate simulation. So they used software to understand the efficiency map for the six-phase PMSM. So speed priority analysis they opted and they have used for six-phase PMSM. So they understood that it's a fast method to evaluate and optimize the different design as well to require or to achieve the requirement. So neglecting the influence of current harmonics and control. Then afterwards they move to accurate efficiency map. That means they will move to accuracy priority mode to get the accuracy efficiency map. Then in this, depending on the investigated machine topology, large deviation, especially for multi-phase machines are observed between the speed efficiency and accuracy efficiency map that they have compared with the help of this evaluation. Then they have understood the different driving cycle because operating region also they can understand with the help of this analysis. So reduction of the power consumption is important to reduce the primary energy demand. At a high maximum efficiency alone is only a first indication regarding the power consumption. So this is their inference from this analysis. So like this, their study also they have carried out with the help of this tool by using efficiency map analysis. So now I want to introduce some of our white paper. All these details we can, it's available in our website, whatever I have mentioned here. So these are the some papers will give you some explanation regarding the topics. So some of the examples I have mentioned here, such a way that it's a motor efficiency map evaluation for the model based development using FEA simulation. It's one of the white paper will help us understanding more about efficiency map. Another one that is efficiency map evaluation considering harmonic loss, comparison of efficiency map with the measurement, and comparison of efficiency map with a measurement. These other papers will help us to understand in details about the topic. So these all the papers can be, and even user conference details, everything will be available in our website that is mentioned here. Now I would like to conclude about our today's discussion or topic. That is in JMAC Designer, actually efficiency map that accounts for the effect of ion loss and nonlinear magnetization characteristics can be created with ease. We have seen it's a very user-friendly software tool, so that can be used to understand our objective, whether it is meeting in terms of efficiency or other lot of parameters. So we have today give importance for this topic or this application. That's what. Then a magnetic field analysis model is created and a response value table is created by performing a magnetic field analysis to obtain motor flux linkage, inductance and torque. Hope you remember about in the discussion we told the way how in the software it is taking place to do the analysis. We can understand from that obviously it is similar to our real-time calculation, but obviously real-time will get, we won't get a very accurate value compared to our tool-based analysis, but the method is similar. But how it is happening with a less time already we have seen in the analysis. And after setting maximum voltage, maximum current control method extra, the efficiency map has created. So here map for efficiency, loss, magnetic flux, power factor and loss ratio for each operating point are displayed. So these all things, not different type of maps we can get it, and these all things we can export it as well in different ways. So that will be help us to do the further further calculation or further investigation or further study everything, it is easy to us to use the all the result. So these are the main inference we can get from this analysis or this study. So hope you have got an idea regarding the topics, and thank you each of you. And now it's a time for a question and answer session. So hope you got an idea. If you're feeling any doubt in any of the point, please keep it in chat. I will try to answer all the question. So that's about the topic today. Once again, thank you all. Yeah, I have some question here. From where the response table is created in JMAC Designer. In JMAC Designer, there is a tab or there is a portion there directly, as I shown in the figure. Once we will click on that response table creation, I can see. I will show in the PPT. Okay, once there is a tab like this, create response table, just we will click on that. So this window will be pop up. Here we can add, as we need to get different operating region, we know the our design variable of current, phase and speed. We can give a set of value on those things, then we can run it. That is the way how we can do the we can create the response table in JMAN Designer. Yeah, somebody is requesting this PowerPoint file. Obviously, after the webinar, we will be sending you all of you the this regarding the PowerPoint. Is the winding setting means, yeah, we need to give the details actually. The question is the usage of winding setting is mandatory when making 2D efficiency map study? Yeah, winding setting means how the winding means how the supply, that things are, as I mentioned in the analysis target, that all things is the mandatory thing we have to give the values. So from that only we can understand the analysis. How to determine LD and LQ by FE analysis? Yes, obviously we can do. Today I have explained the topic was efficiency map analysis, but obviously we can do the LD LQ analysis or LD LQ value by using FEA. There are two methods actually. One is direct method. We have one tool. With the help of that tool, you can directly get your LD LQ value, or we can give some condition. From that also we can get the values. That is possible in the case of LDLQ. Actually, rotor question we can determine with the help, we can determine, and that angle can be represented also as per our required or our designed model. We can get it and we can able to give that value as well. Actually, inverter rating, how can we means estimate the inverter rating to supply the motor with certain parameter? Actually, this tool is the analysis tool, so we have to get those values and we have to import here. So that can be done. So whatever your required model drive details, that we can get it. Then from that value, we can import in this software. That can be possible. Actually, if you are interested to understand the software means, you can go in our website, JAMAG International. There you can get a try this one. You can get a online version. That is analysis analytical tool. Online version is available. That can be utilized. If you are interested more, you can take a 1 month free trial version as well. Then you can go for the procurement also. Which JMAG version give this window for response graph? Actually, recent all of the JMAG version can able to give the response graph. Means recently whatever the available version can be able to 22.2 is recently available for the users can be accessible. Okay, compared to other software, what are the advantage means? It will be mainly I can tell regarding the solver, that is very good solver we are having, and it is very user friendly, as you have seen this example only how easily we can do. And there are lot of other options to understand a new person to more about the software. Like we have lot of option, that is help documents already is available. In that we can get the lot of ideas, or in the website lot of examples for different applications are available. Like that it is very user friendly, and estimation time also it is very less. And we have lot of option to improve our or reduce our simulating time. So in that different way we can tell JMAG is very good compared to other software. Okay, the chat box is enabled only. How we will show the rated region in the efficiency map means that with respect to rated speed or rated speed, we can check which point will be coming. On that way we can understand the rated region of the efficiency map. Actually LDLQ means with respect to that value, how the value is varying, that also can be seeing in the map. That is the meaning of LDLQ map. With the different value, how can be seeing in the different variation in different speed with respect to different speed. So that is meaning of LDLQ map. So hope I have answered for all the question. Uh, if anything else is there, or if you're feeling asked to more, I have already informed that EM design. You can go for the our website. We are giving some online version that is free only, so you can go through that. If you are more interested, you can take the 1 month trial version as well. So this way you can try to use the EM design tool software. That is JMAG. That is a JMAG tool. You can utilize it. So thank you everyone. Hope you have got an idea about the efficiency map by using Jam and Designer tool. Thank you all.
Hello, all. Thank you for attending all this session. So, I am dropping my mail ID and contact number. So, you can contact me anytime so that we can get you in touch on the complete user interface or software demo in person. So, for the particular topic, what you need. So, you can just take my mail ID and we'll get back to you with whatever support you need with our technical team. Thank you.